couple other things I want to talk to with regard to plate tectonics: earthquakes. So earthquakes occur, I think I might have mentioned this before, as basically we have two plates right here moving side by side. We call that transform boundary, and they tend to rub against each other, obviously, and they resist movement, but when they finally move, it creates a shock wave at the focus, and the epicenter is the location right above the place, right above the focus, right above the shock. Yeah. This you might recognize as part of the, I believe that's called the Ring of Fire, excuse me. Ring of Fire in the Pacific Ocean. We have two different plates, Pacific Plate and the American Plate. And so you recognize this is our California along here. So we have the Pacific Plate, it looks like going this way, and the American Plate going this way. So that fault line between two boundaries, between two plates, excuse me, can cause earthquakes. The word is friction. Friction would make it so the plates don't move, but eventually the stress, the energy is created enough so that it just abruptly overcomes the friction, and the rocks will slide into or snap into two new locations, and at the time they do that, they go ahead and create that create the earthquake. Okay. So a few terms: focus is the location of the energy that's released. Epicenter is right above the focus. And we detect, or scientists can detect the waves actually that go through the Earth by this gizmo, which is called a seismograph. So a seismograph is an instrument used to detect the motion of the, this is in bedrock, so detect the motion of the Earth's crust. There's three kinds of waves that then are, created by this energy at the focus. We have P waves, which are longitudinal. That's like the slinky where they pulse it pulses. And then we have transverse waves where it kind of goes up and down. And I've watched a video recently that the surface waves, actually I believe are called L waves, and those are the ones that cause the most damage. Some historical hotspots of earthquakes. Here is Iowa, right here. And we have had some activity down not too far from us. Looks like dates here are the late 1800s and the early 1800s. And then, of course, along here we have all sorts of earthquake activity. Interesting. Earthquakes are measured using a Richter scale. So the Richter scale, actually, each unit is 30 times more or less than the unit before it. And the Richter scale is based upon what they do is they look at the seismograph created at the time of the disturbance, the earthquake, and then they look at how much the pen swings and translate it to magnitude. Notice that 3 actually, 3 on the Richter scale, generally not felt. 7, as it turns out, is will definitely have, it's considered a relatively strong earthquake. Earthquake safety, don't panic. And a lot of these things you can actually apply to any natural disaster and disaster. Don't panic. Okay, if you're indoors, then stay away from the glass. Don't use any flames in case that there's some a gas leak. If you're outside, move away from buildings because they might fall. If you're in a car, stop the car, stay in the car. I thought that was kind of interesting. After the shaking, again, this can apply to disasters associated with severe thunderstorms or tornadoes. Check your utilities, but don't turn them on. But if you have access to a television or radio, go ahead and turn it on, see what's going on. Stay off your telephones. I would imagine this is your corded phone, or I don't know if this would be maybe your cell phone too. Try to keep the lines clear unless there's an emergency. Stay out of the damaged buildings and don't go sightseeing. I thought that was an interesting way to say it. So one of the last things I want to talk about with regard to earthquakes is this idea of a tsunami, and I really like this figure down here. A tsunami is actually associated with two oceanic plates that are moving side to side and creating an earthquake. So here you can see the energy. So down here would be your this would be your epicenter. You can see the energy then going, and what happens is it creates a wave. So we have a wave, and the thing about it is as that wave gets closer to land, the water is actually higher as it gets closer to land. So you can kind of see that, yeah, the shallow wave is a lot taller than the wave out here. So then the problem is when you get a wave on land, it's just a wall of water that's coming inland. So tsunamis have nothing to do with hurricanes or the atmosphere. It has everything to do with earthquakes. This is a pair of before and after pictures of the tsunami that hit Japan in 2011. And so this is the before, and this red line right here is actually going to be how far the Pacific Ocean is going to come up. Now, this was the tsunami that you might remember compromised the Japanese nuclear power plants. And this was the after. Just amazingly devastating. So, you can see this line right here. All right. No, I guess I'm gonna continue this part, that part. This seems like it's a little out of order, but just bear with me. So mountains are the Earth's crust that is taller than its surroundings, creates a mountain. And there's different ways to create a mountain. A common way is that the Earth's crust is folded, or the Earth crust is actually breaking along a fault. So folding, creating mountains, faulting, and volcanic activity. Folded mountains might look something like this. So actually you can kind of see this is a domed mountain, and then with erosion you can get this stuff to go away and it leaves the mountain in the middle there. Fault mountains look kind of like this. Okay, and this is what they would look like right when you can kind of see material jetting up, material jetting down, up, down. After time, this is what they would look like. And a lot of times, well, not a lot of times, I've seen some videos recently where you can actually kind of see this sort of like a ridge and a trough and a ridge and a trough within a series of mountains.